Good morning, sir. My name is S. Niharika, and my roll number is 23401A000 from Department of ECE. Today, my topic is current series feedback in electronic circuit analysis. Introduction of a series feedback. Current series feedback is in this feedback amplifier, both input and output impedance are increased. The feedback circuit is placed in a series with input and output. Here, a fraction of the output voltage is applied in a series with the input voltage of the feedback circuit. In a current series feedback amplifier, a portion of the output current is converted into a voltage, which then it can be a feedback in series with input signal. Then it can be resulting in voltage controlled current source. This type of amplifier which can be increases input and output impedances. Current series feedback. The feedback signal is the voltage Vf across Rn and the sampled signal is the load current I0. Hence, this is a case of current series feedback. Although I0 is the proportional to the V0, it is not correct to conclude that it is a voltage series feedback. Then if the output signal is taken as a V0, then we will get a beta is equal to Vf by V0, where Vf is equal to I0 into Re and V0 is equal to I0 into Rf. I0 will be cancelled. Then we will get a beta is equals to minus Re by Rf. Since beta is a known as function of a load resistance RL, after third basic assumption is violated. Hence, we can say that uh, current series feedback topology to find the input circuit set I0 equals to 0, Re must be appeared at input side. To find output circuit set I is equals to 0, which can be placed here Re also in output side. Now we will get case beta is equal to Vf by I0, that is equals to minus I0 Re by R0, that is equals to minus Re. Beta is equal to minus Re. Then, since the input signal Vi without feedback is the Vs, then we will get a Gm I0 by Vi, HFE IB by Vs. That is equal to minus HFE by Rs plus HIE plus Rs. Then we can consider that it as a equation number 2. Hence, we can write Vs is equal to Ib into Rs plus Hie plus Re. Then Ib by Vs is equals to 1 by Rs plus Hie plus Re. Then D is equal to 1 plus beta into Gm, where D is the desensitivity. 1 plus, we will get here 1 plus HFE Re by Rs plus Hie plus Re. Then desensitivity D is equal to Rs plus Hie plus 1 plus HFE into Re by Rs plus Hie plus Re. Let us consider it as equation number 3. Then GMF is equal to Gm by T. Uh, Hence, we will require D as a equation number 3. Hence, HFE by Rs plus HIE plus 1 plus HFE into Re. It will considered as equation number 4. 1 plus HFE into Re is far greater than Rs plus HIE, and hence HFE is greater than 1. Then we will get GMF is equal to 1 by minus 1 by Re. It is approximately to 1 by B. If Re is a stable resistor, then the transconductance gain with feedback is a stabilized. Then the load current is indicated as a I0. I0 is equals to GMF into Vs. Now we will get I0 is equal to minus HFE Vs Rs plus Hie into Rs plus HFE into Re. Then it will get a minus Vs by Re. We will get equation number 5. Under this condition, 1 plus HFE-RE is greater than RS plus HIE and HFE is greater than 1, then the load current RL is directly proportional to the input voltage, and this current is only depends upon the RE, and it does not upon the any other circuit of the transistor parameter. Then the voltage gain. Here AVF is the voltage gain. AVF is equal to V0 by Vs. V0 is nothing but I0 RL. Vs, that is equals to GMF into RL. Therefore AVF voltage gain is minus HFE RL by RS plus HIE plus 1 plus HFE into RE. Then if 1 plus HFE RE 1 plus HFE into RE is greater than RS plus HIE, then we will get a AVF is approximately 1 minus RL by RE. And the voltage gain is a stable. If RL and RE are stable resistors, then we will get RI is equal to RS plus HIE plus RE. Then RIF is equal to RI into D. RS plus HIE plus 1 plus HFE into RE. Since we can say that output behaves like an ideal current source, which is theoretically has infinite output impedance. Then R naught is equal to infinity, ROF is equal to R naught into D. Here R naught is infinity, then ROF is also infinity. Then ROF, then advantages and disadvantages of a feedback amplifier. Then we can see that advantages and disadvantages. Here advantages of feedback amplifier is improves the stability gain and the circuit of the negative feedback amplifier. Input resistance can be increased by selective configurations. Similarly, the output resistance can be decreased. It will be reduces the noise and distortion by the negative feedback. And the disadvantages like it can be increases the noise distortion in positive feedback. It will can be reduce the gain, and also it is a increase the output gain for the current series and the current shunt feedback amplifiers. Applications of feedback amplifier. We can see that some important applications like it is used in regulated power supplies. Amplifiers with large bandwidth is required, and it is also used in electronic amplifiers. Then concept of feedback is nothing but what is a feedback? A feedback amplifier it can be uses feedback from the output of amplifier back to the input to enhance its performance. This feedback is achieved through a feedback loop, and it can be either positive or negative feedback. Conclusion. In current series feedback, feedback is implemented by sampling a portion of the output current and the feedback a voltage proportional to its in series with a input, resulting in increasing input and output impedances. Thank you for giving this opportunity.